jungle.
Hi everyone, this is Scoop Through. Our group will discuss the topic which is elementary row operation, also known as ERO. By the end of this lesson, you can know that what is elementary row operation, REM and RREM, how to transform a matrix into its REM and RREM. The last one, rank of matrix. For the first one, ERO, there are three operations for the ERO. The first one is called row swap. Exchange any two rows which can be denoted as this RI and then get two arrow between RI and RJ. I and J is mean the row of the number. We can represent this row of number, okay? And then the second, multiply any rows by constant which can be denoted as KRI. This is called scalar multiplication. For the K, it's a constant. You can put any numbers for the K, like 3 RI. This means times 3 RI. Okay. The last one is add the multiple of one row to another row, which can be denoted as KRI plus RJ. This is a row sum. This sum means that RI plus RJ sum plus together. Okay. So for the example, like and then K is 3 and then R1 and then plus R2. This means multiply of 3 times of RI plus RJ like this. Okay. So we move on to the example for the ERO. For the first one is row swap. Performing the following elementary row operation on the matrix. You can see this is a question by given the matrix. And then R1, row 1 and R2 change. This means swapping or interchanging the first two rows. Then the result only change between the question and the answer, the different only the first one row and the first two row, they change their position. So you can see the answer the first one, the row 1 is 1, 2, negative 1. 1, 2, negative 1. And then it changed the position, become row 2. Yeah, you can see it's a row 2, right? And then row 2, they change their position to the row 1. Become the first one, okay. So you can see the question given 3, 2, 0, but the answer given at the result is become upstairs already. Actually, it's a row 2, right? Become row 1. Okay, this the row swap operation works. Now we move on. Okay, the example of scalar multiplication. Consider the matrix. This is the matrix, the question given lah. Performing the following elementary row operation in order. Row 2 change to 3R2. So this means R2 he want to times multiple of 3 times. You get what I mean? Then the result only change is row 2 times 3 only. Another didn't change or what, just like row 2 they times 3 of itself. Okay, so the only change between answer and question is row 2. You can see 2 times 3 is 6, correct? 0 times 3 is 0, also correct. 1 times 3, okay, this is scalar multiplication works. Now we move on to the last one. The example of the row sum is given as below. This one is the row sum matrix, and the matrix given lah. Okay, we apply R1 to R2 plus 4R1. What it means? It means that R2 want to change become R2 plus 4 times of R1. So you can see the question and the answer different between the question and the answer. It's only change the row 2. You can see 4 and then change become 8. Why? Okay, 4 is R2, right? It's row 2. And then we move on and see the R1. We move on to see the R1. R1 is 1, right? 1 times 4 is 4. 4 plus R2, which means 4 also. So 4 plus 4 is 8, right? Also same, the second column you can see. The row 2, actually the row 2 is in the question is -5. So we want to change. Okay? We know that R1 is 2 times 4 become 8. 8 plus R2, which is negative 5. You can change 8 plus 5 is 3. And the last column also same. Negative 3 times 4 and then plus the row 2. The answer is given, negative 6. That's all for the ERO operation. Now I will pass you to Amir to talk about what is the REM and RREM.
For row echelon matrices or REM and row reduced echelon matrices RREM. So first, row echelon matrices. A matrix is in row echelon form when the matrix must consist of at least a non-zero row, and the leading entry, which is the leftmost non-zero entry, must be 1. The leading entry of every non-zero row or pivot is on the right of the leading entry of every row above. All rows having only 0 entries are at the bottom. So all of them are the requirements for a matrix to be categorized in row echelon matrices or REM. For example, as you can see here for REM matrices, first entry, which is located on the leftmost on the first row, is 1, and second entry, which is called pivot, located in the middle of the matrix, and the third entry, which is also called pivot, located at the right bottom of the matrix. And as we can see, both of the first and second entry have zeros vertically bottom of them. For second example, for REM matrices, which is not REM matrices, there is a leading entry on the first row, located at the leftmost of the row, which is 1, and the pivot is located at the rightmost of the matrix, but under it there is other number than 0, which is 2, so that this matrix is not categorized as REM matrices. Example for RREM matrices. Okay, before that, let's look at the notes or the conditions for how we choose row reduced echelon matrices. A matrix is in reduced row echelon form. Okay, so RREM matrices must have every condition that REM matrices have, and the other conditions is each column containing a leading one has zeros in all its other entries. That should mean the RREM matrices have zeros under their entries and pivots. As we can see, for example, RREM matrices have zeros under the leading entry and 1 0 under the second pivot. For not RREM matrices, as we can see, after the leading entry, the first pivot, it have a negative 3 on top of it. So we do not categorize this matrix as RREM matrices.
My name is Yong. Today I'm going to show how to transform a matrix into each echelon forms. First, we need to identify the first pivot of the matrix, which is the top left non-zero entry. Next, make the pivot equal to 1 by row swap or row sum. Obtain zeros for the entries below the first pivot. Moving on to the next step is we need to identify the second pivot of the matrix. Repeat the procedure from step 1. Keep repeating the step 1 and step 2 until matrix in row echelon form is obtained. Final step is we need to get the matrix in reduced row echelon form. Make the element above and below the leading one in each column to be 0. This is the first example of transforming a matrix into row echelon forms. The C matrix is given below. What we need to do is identify the first leading one first, and next we need to change the leading one below of the rows to become 0 by using negative 3R1 plus R2, so that the second row of below leading one becomes 0, and change the third row of first column using R1 plus R3 so that it becomes 0. Moving to the next step is we need to use negative 1/4 R2 so that to change the second row of second column to become leading one. Next, we need to change the leading one of second row below it to become 0 by using negative 3R2 plus R3 so that the third row of third row of second column becomes 0. And last step is we need to use negative 2 over 7 R3 to change the third row become leading 1. For this example, we just transform a matrix into row echelon form, and the final is we get the row echelon forms. This is the second example of transforming a matrix into reduced row echelon form. B matrix is given below, and first step is we need to identify the first leading one in first row. Since there is no leading one, so we need to change the 3 into leading 1. What we need to do is use 1 over 3 R1 so that 3 become 1 and form leading 1. Next step is we need to change the below leadings 1 become 0. So we use 2 R1 plus R2 so that the second row of first column becomes 0, and use negative 2 R1 plus R3 so that the third row of first column becomes 0 to fulfill the rules. And moving to the next step, we need to change the second row of second column become leading 1. So we use 2 over 7 R2, and next we need to change the below leading 1 number become 0. So we use 7 over 3 R2 plus R3, and the following step is we need to change the third row of third column become leading 1. So we use the negative R3 so that it become 1. So now we continue from the previous step, which we need to change 2 over 3, 1 over 3, and negative 1 over 7 become 0. So now we continue from the previous step is we need to change the 2 over 3, 1 over 3, and negative 1 over 7 to become 0. First we use negative 2 over 3 R2 plus R1 so that the first row of second column becomes 0, and use negative 3 over 7 R3 plus R1 so that the first row of third column becomes 0. And the last step is we need to change the second row of third column become 0. We use 1 over 7 R3 plus R2, and the final product is in row reduced echelon forms. And that's it. Thank you.
Rank of matrix. What is it? Rank of matrix is the number of linearly independent rows or columns in it. So what is linearly independence? It means that there is no row or column that can be expressed as a combination of other rows or columns in the matrix. So this one I will explain more details later. So the notation of the rank of matrix can be written as the row and brackets A. So this one is quite important. If the order of matrix is 3 times 3, which is a square matrix, the rank of matrix will be less than or equal to 3. So it means that the maximum is 3. But for rectangular matrix, for example 4 times 3, the rank of matrix will be maximum at 3 also. It will not be 4. So now let's look at what is linear independence. So we are given this matrix and we need to determine is it a linear independence. So what we need to do is we separate the matrix row by rows and times with the constant C. For example, the first row we times with the C1, the second row we times with the C2, and the third row we times with the C3, and then it will be equal to 0. So from this formula, we can derive this number of system. If we solve this system, we find that there's only one solution, which is C1 equal to C2 equal to C3 and equal to 0. So the row of matrix A are linearly independent. So this is basically what is linearly independence. We are given matrix B here, so we need to determine whether it is linear independence or not. So the same way, we separate the matrix row by row and times with the constant, and we get this formula. From this formula, we can obtain this number of system. So obviously, if we look at this number of system, the second row is twice of the first row. Okay, therefore the rows of matrix B are linearly independent.
So okay, now I'm going to introduce a few ways to find rank of matrix. The first one, we are going to use minor method. The second one, we are going to use REM or RREM.
So let's proceed to the first step, which is using minor method. So I will simply introduce what we need to do in the minor method. So the first step, find the determinant of the matrix. The second step, if the determinant not equal to 0, then the rank of matrix is equal to the order of the matrix. If either the determinant equal to 0 or the matrix given is a rectangular matrix, then reduce the size of the matrix and find the determinant of the submatrix as well. If the determinant is not equal to 0, then the rank of matrix A will equal to the order of that particular submatrix. So if I explain like this, it might be a bit complicated. So I have prepared a few examples to explain about it. So the first example, we are given the matrix M here. So the first step, calculate the determinant. Okay, so the determinant is calculated by this formula, and we obtain is negative 18. So negative 18 is not equal to 0. So the rank of matrix is equal to the order of the matrix, which is 3. Next example, we are given this matrix and then calculate the determinant also. But this time, we obtain 0. So what we need to do is, we need to reduce the size of the matrix, become 2 times 2. Okay, so we can take this 1, 2, 4, 5, and we get this matrix, and then we calculate again for the determinant. So now we calculate the determinant, which is 5 minus x equal to negative 3. So this time, the determinant is not equal to 0D. So the rank of matrix will equals to the order of the particular submatrix, which is this one, is 2 times 2. So the rank of matrix is equal to 2. So the last example, we are given a rectangular matrix. So what we need to do is, we need to find the determinant of the submatrix with order of 3 times 3. For example, this one. We can take 1, 2, 3, 5, 6, 7, and 9, 10, 11. So we calculate the determinant of this matrix, and we obtain 0. So when we obtain 0, what we need to do? Which is, we need to reduce the size of the matrix. So now it's reduced to 2 times 2, which we take the number of 1, 2, 5, and 6. Okay? So same, we calculate the determinant again. Now we obtain negative 4. So it's not equal to 0 anymore. So the rank of matrix will equal to the order of this matrix, which is 2. So the rank of matrix is equal to 2. So the second way, which is reusing REM or RREM. So in this way, the first step is we need to change the matrix to its REM or RREM. So the rank of matrix will be equals to the number of non-zero rows in the REM or RREM. So the non-zero rows means that there's a row in the matrix which contains at least one element that is non-zero. So now let's look at this example. We are given the matrix A. So we need to calculate how many non-zero rows in the matrix. Okay. So the first row obviously is a non-zero rows because it's not contain any zero element. But the second row, we contain one zero element here. But then it's still categorized as non-zero rows because we have non-zero element here. So it's still categorized as non-zero rows. The third row is that we have non-zero element here, so it is non-zero rows. But the last row, there's all is zero element, so it is not a non-zero rows. So we have only 3 non-zero rows, so the rank of matrix will equal to 3. Let's look at this RREM. The same way, we just need to calculate how many non-zero rows here. The first row, we have 1 here, so it's a non-zero rows. The second row, obviously, we have 1 and 2, so it's non-zero rows. The third row is same, is non-zero rows. The last row is contain all zero elements, so it is not a non-zero rows. So we have only 3 non-zero rows, so the rank of matrix is equal to 3. So it is almost the end of the video. So we have already covered what is ERO and what is REM and RREM. And also we have covered how to transform a matrix into its REM and REM. And the last part, we have already covered the rank of matrix. So thank you guys. This is the video presented by Group 2. So thank you.